We'll let just a couple more minutes, and then we'll get rocking and rolling. I talk Launchtube today. I feel like there's been a lot of questions and confusions around exactly how Launchtube works, what it's doing, how to use it. I'm not going to say it's non-trivial. Kind of depends on what you're doing, but there's some flexibility there. Once you get it set up, it's one of those nice things that it's kind of, you set it up once and then it's correct and it just keeps working, as I've done for that kale project where the web is using Launchtube. All right, let me. Should we look at a graph to start us off? I feel like graphs are always the right place to start. Let me find a graph. Find a random graph. Let's pull this one up again, just because it's a good one. Hold up. Sorbonne network adoption. We can look through a couple of these. All right, screen share. The weekly runaround of which screen do I actually want to share? Let's share the entire of this screen. So our Sorbonne mainnet adoption metrics, the one that I love the most, the total Sorbonne transactions. Let me pull that down. Hit a new record yesterday. Almost, just shy of 280,000 total invocations. Pretty incredible. And I think we're on track. Maybe it's only 1 o'clock, or it's going to be close. We're on track to maybe break it again today. Pretty incredible. One of my favorite, so there's this on Dune, public dashboard here. It's probably really tiny for y'all. We've got our total smart contract invocations, 6.1, almost 6.2 million. And then if I go over to my Postman, I've got a metric here. Oops, F. Hit the navigation bar. You can look up, let's see how many Launchtube transactions we've submitted. Then I can do some quick math. 4.7 million up against 6.195. That's just over 77% of all Sorbonne invocations going through Launchtube. So if you're not using Launchtube as a developer, I would recommend considering it. It's battle tested. It's going quite well. We're when I say we, I really mean I'm trying to get some ecosystem support. So like some of our third-party RPC providers to also spin up their own Launchtube. So that maybe we can get some more ecosystem participation. So it's not just me running Launchtube. But let's back up a little bit. What is Launchtube? For those, the uninitiated, go to GitHub Stellar Launchtube. This is a project that I launched last year with the basic premise of trying to make it easier to get transactions on chain, particularly given the advent of Sorbonne, where when you submit a transaction to RPC, you submit it, well, you simulate it, and then you submit it, and then you run a bunch of get status. Is it on the blockchain? Is it on the blockchain? Is it on the blockchain? Is it there yet? Which is all a bit annoying and error prone, especially if you're doing, if you have any time difference between simulation and submission. There's a potential, if you're in surge pricing or something, that the simulation budget will be incorrect at the time that you finally submit it. So it's nice to have a service that does all of those three things together. There's the other issue that if you're using a smart wallet, which doesn't have the ability actually at all to submit transactions, you cannot use a smart wallet, a C address, to submit transactions. Right now you have to use a G address. A G address both can hold lumens, but only one can submit a transaction to the network. Maybe that'll change at some point, but it does now require that if you're using smart wallets like I am in all of my activations, you have to maintain some sort of G address logic and now the smart wallet logic to get a transaction on chain. And Launchtube just obfuscates all of that away. Gives you a synchronous endpoint to submit a transaction, and then it'll just poll in the background until it finally finds some response or times out, and will give you back a response. It manages the G addresses both for the lumens, so to pay the transaction fee to get the transaction on chain, but it also pays the sequence number. So the sequence number being you can only have one account is only allowed to submit one transaction per block. And so if you want to maintain any sort of throughput or high concurrency with lots of transactions, you've got a lot of users that are trying to get on chain all at the same time, you have to maintain some sort of pool of accounts that can pay the sequence numbers, kind of like a nonce, I guess. So the way that this is done with Launchtube is you've got one account that pays the fee, and then we use Stellar's fee bump transaction, which allows you to have one account that pays the fee and a different account to pay the sequence number. So I maintain a large collection of pool addresses. Right now I've got 500 pooled accounts. They don't pay any XLM to get the transaction on chain, but all of them will pay the sequence number. And then I have one address that pays all of the XLM. So that's, I can pull that address up here. That's this one right here. So all of the fees for Launchtube get paid out of this address. But you'll notice each of these addresses is one of my pooled accounts, which is quite nice. So that separation is really nice. It's a little bit tricky to maintain as a developer, especially if you've got to rebuild it every time you build a different app or transition to a different setup or something like that. So having a service that can maintain those is nice. The other two pieces being a simulation of your transaction, which is, it's not that hard to do on the client side, but it is nice to have a service that can do the simulation and the submission really close time-wise together so that you have the best chance of having the right budget. And then last but not least, it does the polling. Once you've submitted it successfully, that doesn't mean that it's on chain yet. It just means it's kind of like in the mempool, I suppose, where it's trying to get on chain. Maybe it will, maybe it won't. Maybe it'll get in this block. Maybe it'll get in the next block. We're not actually sure when it'll get online or on chain. But whenever it does, we'll either A, send you a success, a failure, or a timeout. So all Launchtube simulated transactions have a default timeout of 30 seconds. So if your transaction has not made it on chain in 30 seconds, it just errors out with the timeout, which is nice. You should do that regardless of whether or not you use Launchtube, as have really definitive, defined timeouts on your transaction, so you know when it's safe to assume the transaction is not going to make it into the ledger. This becomes increasingly important as we hit surge pricing and ledger or transactions start to get bumped further and further out for whatever reason. Okay, so that's the service Launchtube. It has both a testnet implementation and a mainnet implementation. We did have a testnet reset recently. So I know I was maintaining a pool of testnet accounts. I'm sure all of those accounts have been reset now. So even today, as we're testing on this, I may run into an issue where those sequence pool accounts do not exist. And so we may run into that issue. I'll have to look at that, but the mainnet's certainly up and working fine. If you're on testnet, you can so the way that this works is it's a service that you have to authorize with some sort of JSON web token. With testnet, you can generate your own tokens just by running gen, and it'll give you a nice Launchtube token. If you are using mainnet, you'll have to either A, ask us in the Discord for a token, either our Discord or the Stellar Global Discord. Or I just added recently, if you're kale farming, you can go and buy Launchtube tokens. One of the first things you can acquire with kale, you can purchase your own Launchtube tokens at a significant discount for the kale to XLM, with a major caveat being you can't take Launchtube XLM and do anything with them other than pay to get transactions online. So don't get crazy and think, ooh, here's my chance to go and get a bunch of lumens. You can get a bunch of tokens that'll allow you to submit transactions on mainnet, but that is all that you can do with them. So this is the URL here for like the documentation. There's all of the API endpoints and the arguments that they accept. All the code obviously being open source. And if you want to run your own service, this one's running on Cloudflare. It's very, very cheap to run. You do need to maintain a pool of RPC endpoints. So I'm currently using third-party RPC providers to actually do the submission and polling and whatnot. So you'll need to maintain a list of that. So that's probably where most of your cost is going to be, is standing up and maintaining RPC relationships. But when you're not running at the high load that I am, it should be very cheap. And you can find all of those RPC providers over on our developer docs. Inside of data, there's an RPC section and then a providers tab, which gives you all of this wonderful information about who our third-party service providers are for all of our RPC endpoints. Super handy. All right, so enough yammer yammer jibber jabber. Let's start coding. What I want to try and do today is open up a really basic, we'll do like a Stellar Asset Contract transfer or something using Launchtube to get the transaction on chain. And I'm just going to stand up a really basic bun.js project for that. I've already stood one up, but I'm going to tell you what, let's go ahead and nuke it. I'm going to move back over and pull this in. And I'm going to make a directory. This is probably really tiny. Make it biggin. Make directory, let's call it Coding with Kalepail Launchtube Tutorial, LTT. We'll change directory into that. Nope, that's the other one. That's my example one that I was working on earlier. And then let's do bun init, blank project. Open that up in my code editor. Make that big. That's a little too big, maybe, if such a thing were possible. And then to run it, we just do bun run index, and you can see we get hello via bun, which is just this console log in there. Okie dokie. There's two packages that I want to install. The first being our, that's npm bun add stellar SDK. We're going to need that for sure. I'm confident. So I'll go ahead and add that one. And the other thing that I want to make sure we add is the Stellar Asset Contract TypeScript bindings. So I'm going to generate some Stellar Asset Contract TypeScript bindings so that we can more easily interact with the Stellar Asset Contract. This actually is because I have the passkey kit, which uses the Stellar Asset Contract. I actually have there's an NPM package out there you can install, but I'm going to show you the manual way to do this, which hopefully will also serve for anybody that's either unfamiliar with TypeScript bindings or has never actually used them to stand up contract bindings in their project. So the first thing I'm going to need in order to run, you have to run, I think it's Stellar Contract Bindings TypeScript. In order to be able to run that, you're either going to need a WebAssembly file to run it against to generate the bindings, or you'll need a contract ID in the network that contract ID is on. For Stellar Asset Contracts, we don't have binding, or we don't have WebAssembly files because they're host functions. So we're going to need a contract ID. So Stellar Contract, I think it's asset. Yes, and we need an ID of the native asset on testnet. So network testnet asset native. If this was any other asset, you would do pizza or whatever the asset name was, and then the issuing account G address. But XLM is just native. So there's our address. Very nice. And then we do Stellar Contract Bindings TypeScript. Wow. Contract ID, network testnet, and output directory. I'm going to do the Stellar Asset Contract SDK. Cool. So now we should have a package, a directory here now that's our Stellar Asset Contract, and it's got these generated TypeScript bindings, which are sick. You can modify these. I often do. I don't like to use the exported libraries from inside the TypeScript bindings. I will import those myself, and then a lot of times there's exports that are not used. You can see with this kind of like grayed out coloring. So I like to remove those if they're not being used, just to clean the package up a little bit. That's typically all that I'll do. If I'm deploying onto, like, sometimes you may want to use the minimal or no Axios version of things. So you may want to switch over your imports from the Stellar SDK to the minimal version. I also think this may not be using the most recent version. Yeah, so I'm going to upgrade this to 13.1. This is 6.03, and I think this also probably needs to be updated. And then I'm just going to put the little stars so that it keeps these up to date. Great question. I think I'm using Dependy. Yeah. Nope. Yeah, manage dependencies and vulnerabilities in Rust, Go, JavaScript, TypeScript. So that one will show both the Rust packages as well as NPM. Great question. I'm just going to scroll through that. So if anybody ever wanted to see what, I don't have many extensions. All right, chill. Python's a garbage language, and I tried to get the help that I need, and I'm sure it wasn't helpful. Okay, so we've installed the TypeScript bindings. We haven't built them yet, and this one's tripped me up a couple times. The TypeScript bindings used to build the bindings. They don't anymore. They just pull down the index file. So I'm going to need to change directory into the Stellar Asset Contract, and I need to run bun install to install all of the dependencies, and then I need to run bun run build, which will generate the actual bindings. You can see those now in the distribution where I've got a TypeScript file and a JavaScript file, so that when I go and I import them, it'll import the correct package. I'm going to run bun link, which will give me a nice little output where I've registered the Stellar Asset Contract. I'm going to change directory back into my root, go to my package directory, put in the dependency for the Stellar Asset Contract SDK that we just built, bun install. I'm going to run bun install first. I don't think I need to do this, but just to make sure that everything's fresh and clean. All right, so we should be good inside of our index file now to begin using that new import client from the Stellar Asset Contract SDK. We can do const Stellar Asset Contract. I know you guys just want me to say SAC, so I'm just going to say it and get it out there. You've been wanting me to say it. There you go. Got it out of your system. Let's keep moving on. Contract ID is what we also need. And then the last thing we'll need is a network passphrase, which will be networks. I'm going to make sure I grab that from the right place. I mean, I could grab it from anywhere, I guess, but I like to get all of my dependencies from the right place. The other thing you'd want to make sure is that your Stellar SDK version here is the same as the one in here, or else you're going to get like type issues. So making sure that your Stellar SDK for your bindings and your actual project are the same will keep you from having type errors later on. Or if you are having type errors, try and check that. You can also do things like the bun pnpm or npm package overrides, but we're not going to fool with that today. The contract ID we already got right here, which I think we could just use. It imports from, it's net. Just have a network export. Yeah, networks, and you could export the networks dot. I think it was probably testnet or something like that. I could look that up. Read only .testnet, and it would have the network passphrase and the contract ID already baked into it, like we used when we were building in the CLI. It gives us those. I really hate using these because sometimes I will change, like I guess for the Stellar Asset Contract, it doesn't matter, but I'm constantly updating my contract ID because I'm making little tweaks to my contract. And this will just come back and bite you all of the time that you don't have the right contract ID, and you'll just forget that you never rebuilt your TypeScript bindings because you didn't really think you needed to, because you probably didn't need to because of the thing you changed. But if the contract ID has changed, you'll need to change the contract ID. So I always like to make sure that that is put in explicitly as like an environment variable, so that when it changes, I am aware that it changed and can, even if my bindings haven't updated, I can make sure I'm pulling in the right contract ID. I like to do the same thing with the RPC, so that I absolutely know what RPC I was using, which I'm going to go back to the developer documentation here and go to the RPC providers, and then there's some publicly accessible APIs. I'm going to be using testnet, or at least I'm going to give it my best shot with this RPC URL, the SDF one. And we'll just paste that in there. Probably want those to be environment variables, but whatever. YOLO, baby. Stellar asset contract. So now we've got this. You can see we've got the nice TypeScript binding, so you can see all of the arguments that are available. I mean, the TypeScript bindings, if you're not using these, you're doing it wrong. TypeScript bindings on contracts are absolutely incredible, and they're so easy to build. It's just that CLI command, and it builds TypeScript bindings. It's amazing. I'm going to do a transfer. So I'm going to look up transfer. It'll give you arguments that you can use. You don't have to worry about XDR or weird SC val conversions. You can just use from to amounts. It's all as JavaScript would intend. It's beautiful and amazing, and I love it so much. I'm going to go from, I have no idea what address I'm going to use, to, I have probably the exact same address, and then the amount. This is in stroops, so 10 million times. So I'm going to do big int because that's what an I-128 is. So 1 times 10 million, that would be 1 XLM, assuming that this is the Stellar Asset contract for the native asset, which it is. But you could use any asset that you've deployed, uploaded, bound, I don't remember what it's called, deployed. Make it the kale one. And then this will be the amount of kale instead of XLM. All right, but we need to transfer from and to an address. So I'm going to open up this again and go to the laboratory and just generate myself some new accounts on testnet. Generate a key pair. I'm just going to grab the secret key. Put this up here, const key pair equals key pair from the Stellar SDK from secret. All right. And I'm also just going to go ahead and put the public key, pub key inside of key pair public key. And then I'm just going to transfer from myself to myself, pay myself a nice big 1 lumen bonus. Put that in a await a promise, and this will be a constant variable of the assembled transaction. So you get this nice little output here. Assembled transactions, what it's going to send back. And then inside this assembled transaction are the components that you'll need to get this transaction online. The big one being that we haven't signed it yet. So there's a nice little at sign and send method. So this is what you would do if you wanted to not use Launchtube and use your own XLM, with the caveat being, again, we're using a G address or a classic address here, so it will be able to submit transactions. But if the from and the to were a C address, this wouldn't work. You would have to use a G address at some point. So this is another reason that Launchtube is going to be very important, or some services like it. All right, we'll await this. We'll run into some issues, but we'll work through them. Const res equals, and then we'll log res. All right, let's start working through our bugs that remain by running bun run index. The first one that we get is probably that there's no lumens, and that's because we never generated the account. So let's make sure we fund this account with friendbot. If you ever wondered what these errors mean, sometimes it tells you, especially if it's a Stellar Asset contract, the account entry is missing. So in that case, I know that the account has never been created. So now we have successfully funded that on testnet. So we should get a different error. These Stellar Asset contracts, they now put out better errors. Sometimes they didn't used to. And if you were wondering on the guest side, this is just like a little pro tip for all of my super users, if you go to the Sorbonne environment, inside of, I think it's guest source, it might be host. I think it's host. Inside of the host environment, you get built-in contracts, and those built-in contracts have contract errors. Inside of those contract errors, you can go from the number, like this one, number 6, and get some idea of what the error actually is. So that's actually super helpful when running into errors you're not actually sure what they are or where they're coming from. Maybe they're deeply nested inside of your contract. If it's coming from a built-in contract or a host contract, which right now the only one we have is the Stellar Asset contract, we have all of these errors that are documented here, this one being that the account missing. There's also like a balance error, which you may see sometimes when you don't have enough funds. Maybe the trust line is missing. So if you see that yummy number 13, you know that your trust line is missing. This is going to pop up a lot for people that are jumping in between G addresses and C addresses, where the C address, the contract, smart wallet, it doesn't need a trust line. But if you're running on a classic account, it does need a trust line. And so you'll be missing, you may hit that number 13. All right, so we funded our account. So now it should have both lumens. And it exists and has lumens. So now we should run into a different error. We do. You must provide a sign transaction function. So we didn't ever sign the transaction, which is a bit of an issue. We have a transaction, but it is not authorized to be sent. So we need to add a signed transaction. I think we could add it inside of here, but I can also just add it to the client, which will then assume for any other signature that we need, it'll just borrow this one. I'm going to use the built-in, I think it's called basic signer. Yeah, basic node signer. Pass it in a key pair and then sign transaction. So you could write this up yourself, or you can just use this one. This one works just fine. Okay, so that will ensure that when we hit sign and send, that it'll actually sign it. It'll be able to sign it. And so then when we run this again, let's see what we got this time. Oh, actually, I have no idea what that one. Transaction requires signature, C, needs non-invoker by. From, oh dear. That one's a little puzzling to me because it should, yeah, it should be, right? Because it's grabbing it from here and then puts it in there. And then that should be the from and the to. It is possible that I need to add it here. I don't think so, though. Let me look back at my other code that I had. Oh, well, it might help if I saved it. That wasn't it. You never know. You never know. Let me actually take a look at my public key here. All the networks look correct. Am I awaiting? Yeah. Look on testnet, just make sure that it actually exists and looks correct. Yep. Well, that's a weird one for sure. Let me try and it should simulate on its own, especially when it gets this error. This is an error that you get after simulation. This typically happens when the address that the transaction is signed by is different than the address that the require auth is on, which is definitely a bit puzzling to me because those should be the same. What we can do though, a nice little journey. Maybe the journey all along was never to use Launchtube. It was actually to be able to learn how to debug contracts. We can look at the built. Well, you should be able to borrow the authorization if it's a G address, but we can take a look. You're exactly right. I need to do that. So the bindings by default, and we just saw it when we looked up our XDR, it just grabs a goofy 000 null address, and that's what it will use. And so then when you are inside of an operation, the credentials will be the actual account itself. And so the signature right now is void because it can't borrow from the actual transaction signature. However, if I make this source account the same as the argument that will be required, the authorization will be required, then it can borrow source. So in that case, if I save this and then I log that transaction again, what you're going to notice when I paste this in is that where I have credentials here being a whole object, which is the address of the address that we'll need to require auth for inside of the actual execution. This will now just say source account because it will be able to borrow this signature from the outer transaction. So let me demonstrate that here. This should succeed now, and we'll get this. And then when I paste this in, we'll notice that the auth right now, the credentials is just source account because it's borrowing it because instead of having a 0 address, we actually have the source account of that require auth account. And that's because when we spun up our client, we said use this public key instead of a null account or a null address as the source of any transactions that we build. Good catch, everybody. Look at us. So we don't need this. We can just use this again because we have that public key. Okay, but that's not using Launchtube. We learned a lot, which is wonderful. Go us. And we are getting transactions on chain. The big issue being we have to pay our own XLM. So if we were to refresh this, assuming that its caching is quick, we'll notice that we have less XLM because we had to use our own lumens to get this on chain. So that's one of the things Launchtube is going to solve for us is gasless transactions by using the Launchtube account to get transactions on chain for the fee, which becomes incredibly important when you're not using a G address for the exact reason that we just noticed that a C address can't pay those fees. And so you're going to have to use, with a C address, you have no ability to use this source account because a C address can't be the source of the transaction. And so in that case, this credential is always going to be filled in, but instead of a G address, it'll be a C address. And then something like passkey will need to generate the signature for the invocation itself. All right, so let's go ahead and switch over. Let's not sign and send, but instead let's build up a Launchtube invocation here. So we'll build a fetch. Let's put in the I think it's test https testnet.launchtube.xyz, and this is the method post, and the headers will need an authorization header with a bearer token. I'm going to go ahead and gen myself do I have one already? No. Testnet Launchtube gen. We'll get this const Launchtube token, my Launchtube token, and we'll use this in here. And then the body is actually a form. So we'll do const form data, new form data, and then form data will append an XDR, which is the built transaction .xdr. Okay, Now, obviously, we haven't signed anything yet, so this will not work, but we're getting close. We should at least be getting errors now from Launchtube. So let's await that const res log out that result. And let's see what, let's save and let's see what we get as far as errors. All right, we're getting a bad request. I think that's probably, I don't actually think that's a very good, I think that's probably the wrong, oh, let's make sure we do a then async. This will actually get us our errors. If res is okay, return res JSON, otherwise throw await res JSON. That should give us a better error. All right, we can look at our error result here. It's given to us. I'm pretty sure this is going to be a signing error. Can we just have a moment for applause where you put in XDR and now it gives you a possible type? Because there's a lot of XDR to choose from. So having a possible type output with popular is amazing. It's never not been right in my experience, that is amazing. Congratulations to whoever designed that. Anyway, TX bad auth. That's what we expected. We haven't even signed this transaction. So we definitely need to do that. I'm not going to get into, probably not. Yeah, I don't think, we definitely should get into how to actually sign inner transaction. And maybe that's what we should try and do here. It's always a little bit tricky to get an inner transaction sign, but there's a tool here for this, and it's called assemble transaction sign auth entries. And I might actually sign it just fine because I'm not using a C address. So let's just see what happens when I do that. No unsigned non-invoker auth entries. Maybe you already signed. I think I probably am going to need to simulate before I try and sign something because there's no auth entries to sign at the moment. Because if we look at this, go ahead. From the top here. Good idea. Because we don't need that anymore, I think. Yeah, so no auth entries for publicly undefined. So that we may actually need that one. I'll be curious if we need to, I'm pretty sure we have to simulate because my guess is in this case, we don't have any auth entries. Oh, we do have auth entries. But it's trying to pull in from source account. Wait, this is an old one. It is possible that when I try to do sign auth entries, it's not going to get it. Let's see what it looks like. AT build to XDR. Let's see what the XDR actually looks like at this point in time and see if it has auth entries, because my guess is that it doesn't. Ah, it does. It's trying to sign for that. It could be that I need to include more information so it knows what it's actually trying to sign, which I think it does take a sign auth entry argument. It also takes an address. So let's try and give it an address of a public key. And I think we probably need to include a sign auth entry because we included sign transaction, but we haven't included a sign auth entry. And that's where things get a little bit gnarly in that you have to start importing some other libraries, which again, I would really like to walk through, but I would probably need to be a little bit more prepared because I spent so much time doing this in passkeys that I ended up just building out a new authorize entry instead of sign auth entry. And at this point, I've got no idea which one I want to use, to be perfectly honest. But I do know that if we keep this, we can borrow the source auth, and then we just need to tell a Launchtube not to simulate. So if we do a wait at sign, I think we might have to include some information more specifically about what signed transaction method we need, but we can go ahead and try and run with that and see what happens. We get the error. Oh, this one, is that one the same one as the TX bad auth? I think that may be because, well, it's probably two things, but I know at the very least we're probably going to need to make sure that form data is not simulating. And the reason for this is we don't want, if we're going to be using source accounts, we can't have Launchtube simulating for us because it won't be able to borrow the signature and use its own sequence number because we don't want to be signing for an account that isn't owned by the user, in that case, the Launchtube sequence number account. I don't think this will actually fix anything because I still think we haven't signed the transaction appropriately. And I think that's because this is not updating the inner. So if we looked at this, which is what we passed it, if I had to make a guess, I would say that the transaction, it is signed. I wonder if the testnet version of this doesn't actually have this quite yet. Let's look at the error because the error may still be the same. Oh, I know what this is. This is that thing I was talking about before where testnet, all of the C addresses that I'm trying to use don't exist because of the testnet reset. So my guess is this... it's not able to sign with this fee bump account, which is this one right here. No, this one right here. Probably because it doesn't exist. But I think there's a lot of these. So even if I were to try and, which I can go ahead and try this now, fund that account, my guess is it will still fail unless it grabs the same sequence number account, which it might. I don't know exactly how that orders putting it back. Let me see if this is the same account or a different one. That looks the same. That was the one that we just created, right? Oop. GAW. Maybe this was the one that I need to create. Is HM... No, that's that one. That's the inner one, which is probably fine. That is a little puzzling because it's doing correctly on not simulating, which is good. The error for this is a little bit puzzling. I wonder if it's I think the yeah, that one's a little bit puzzling. I'm not actually sure. I think it's something to do with the reset, though, where maybe these accounts needed to be subsigners or have the fee account as a subsigner so that it only needed one signature. But I don't actually recall. Regardless, on mainnet, this is the way that you'll accomplish some of this. I am going to give a little bit, since I have a tiny bit of time, I am going to try and muddle through this sign-auth entries component. Where I have because basically the only thing the Launchtube actually needs is the Soroban components, the Soroban operation items, the authorization entries that have been signed, and the actual arguments for the operation. So like the contract that you're invoking, the function, and the arguments. But the outer transaction is actually completely relevant. And if you look at the documentation on Launchtube, which I must have closed at some point, you don't actually have to pass it an XDR at all. You can, or you can pass it a function and an array of authorization entries. So you don't actually need to pass it a transaction at all, because on the Launchtube side, it will build its own transaction with the outer fee bump being the transaction that will pay the fees, and the inner being the one that will pay the sequence number. But all of those other pieces don't really matter. The only thing that would matter as far as the thing that you're trying to get on chain is the Soroban entry, the Soroban invocation. So really you only have to pass it a function, which is this host function XDR, and an array of authorization entries, and making sure that those are signed appropriately, right? So not using the source account credential, but using the actual credential that is explicit to the inner Sorbonne invocation, smart contract invocation. Let me see if I can get an example of that. So if we had public key be the default, this should now be an XDR. I think we'll probably get signature errors on this one. Well, that's helpful. Sign auth entry or a custom authorized entry. So if I paste this in, this should show you what it looks like when you're starting to sign a credential with explicit auth. So even in the case of a G address, you can do this. You just have to include your own nonce, signature expiration ledger, and the signature. And that's what this sign auth entry element is going to get us. And I think it's possible that the basic node signer actually has this. I don't have any idea if it will work. I have not used this in a long time. Oh my goodness. Success. So it actually worked perfectly. So I have no idea why it didn't work before, but that did work, which is amazing. I'm actually kind of surprised that it worked when I had simulation off, but maybe the testnet always simulates. Oh, I had it commented out. That would be why. Hey. So this is probably going to throw an error because it hasn't been simulated. So we definitely want to simulate that. And ultimately, the less you can pass to Launchtube, ironically, the better. You can pass more information, custom fees, simulation, those items that are outlined in the docs. But the less you can give it, the more the Launchtube will figure out on its own, and it tries to be as smart as possible, which is really nice because your fees will be as low as they can possibly be. The timeouts will be reasonable. The signatures will ensure that they're correct, those types of things. If we look this up on Stellar Expert, oh, that was the public network. We can see that transaction went through. We can see the fee was paid there, which is super nice. Again, all of that information, you can see everything that happened here on invoking that Stellar Asset contract, the transfer from myself to myself for 1 lumen. All super nice. I think, again, if you were to look, I don't know if we tried to do any more G address stuff, but if we look here, 991432, let me open this up out here just to make sure that this one's going to be more current than Stellar Expert for sure. 99143, so it's 320. Let's remember this number. Okay, so this is like proving to you that you can get transactions online in a gasless way. So we'll save that, and then we'll just rerun this again with Launchtube, paying the fee. Wait for that to succeed. There we go. And then if we refresh this, that balance shouldn't have changed at all, which is amazing. Free transactions online, asynchronous, didn't have to do any getting, just one simple fetch call to Launchtube, and we're on chain. I am still a little bit confused on why that signature didn't work. I guess we've got 8 minutes to try and debug that, because that is puzzling to me. I'm going to try and remove. I know I'm going to need the outer source. I don't know if I need the inner source. I don't think I need to sign auth entries. I think I just need to sign the transaction, and I know that my simulation needs to be false. And we get the error. Let's take a look at our transaction. And this may just be a bug with testnet Launchtube that I need to go and look at later. So the main part of our demonstration is over. Credentials, source account, MJ3. What did we actually sign with? C2HHR. That's this one, right? Yes. So it does seem to be signed correctly. It could be that... Go ahead. Let's take a look. think it's like the fee that gets charged that looks different. TX bad auth. Super interesting. Because the transaction looks correct, but it could be, do I need to include like, I mean, it's possible that like by default, it's grabbing the wrong sign transaction. Let's put in an explicit basic node signer just in case it's borrowing the wrong thing. Simulation is false, which is good. What happens when I turn that off? It's the same error. So it's erroring before it gets to anything else. Yeah, I'll have to look at that one after I shut her down. I need to go look through the Launchtube code and see exactly what's going on in this particular instance, because this transaction looks correct to me for submitting something that is signed. That's you are able to use the borrow source account so long as you don't simulate. And we do have a signature. So, oh, there's nothing signed on the inside. You are, wait, why is it signed on the outside with my, this is not fee bumped. Oh, it is fee bumped. Oh, wait. Oh, okay, I'm missing this signature. You're correct. That is the funding account. This is the inner. So it is signing it, but it must not be saving it to the actual signature for the built transaction. And that is probably a bug, especially because this does not output anything that can update that. I wonder if that's very interesting. So if I do log bill XDR here after I've signed it versus before I've signed it, does it look any different? No. Doesn't, no, it's not. Okay, so that's definitely the error. It's not actually signing it, or it is signing it, but it's not saving the signature to the transaction object, which is an issue. That sounds like a bug, so that should get filed somewhere. Look at us, solving bugs, finding issues. Okay, well maybe, okay, hold on. Does this give us any information to sign the transaction? Sign this function did not previously include one. You need to include one now. Well, that's just for the sign. Let's just include force just in case. Maybe it doesn't think it needs to be signed, but in fact it does. Nope. Is there any other there's no other like, there's sign and send, which we don't want to do. We just want to sign auth entries. That's not what we want to do because it's source. I mean, maybe we could try doing sign auth entries and see if that works, because it's essentially the same thing, right? I'd be curious what it does when it finds a source. Does it just yell at you and say you don't need to sign for it? Let's await. Yeah, you don't need to sign because it's a source. Well, I'm trying to sign with source, but it doesn't save it. All right, well, there you go. I'll file that as a bug. We can rack that one up to a community-driven error issue. There is definitely ways you could get around it. You could build a new transaction at built to XDR networks testnet sign key pair and do const tx. I'll get rid of these for now. And then this I think is a, why does it say void? Oh, because it's signing tx sign. And then instead of sending this, we send this. And hopefully that will have the correct signature and will be successful. So bit of a janky solution when there seems to be a function that should solve for that. Looks like we're not logging the result here anymore. But that should be successful. I am going to try the simulation off again because that should definitely error. Okay, we're back to successful, so that's good. And we'll look at this envelope XDR and you'll notice that we're not using source account anymore. We're using the actual credential. Or no, we should be using source account now. Again, we were using the other one before. Now we're using source account. But if I start using simulation, actually, I've switched the code. I remember now on the back end that if you do simulate and it doesn't need to be simulated, it just automatically switches this to false on the back end. So it doesn't really matter what you include here. You could include true and it's not going to simulate. I think it even tells you when it comes back that its simulation is false. Maybe it only includes those in an error. Yeah, it looks like it only includes those in an error, which is fine, but whatever. Both of these should succeed because if the backend finds that it's using source count, because I had some people that were throwing errors there even though they were signing correctly, and it just didn't make sense to throw that error versus just if it doesn't need to be simulated or if it can't be simulated, just don't. Okay, cool. Well, we solved that one. I'm going to file a bug for sign, not actually updating the transaction. You all are Launchtube experts now. So go forth and Launchtube great things. If you need tokens, and I'm sure you will, just ask in the Launchtube channel here. Or, of course, over in the Stellar Global channel, we've got some community folks that have access to issue tokens. Or, of course, you can go and farm some kale and purchase your own Launchtube tokens. There's 101, also known as 3, different ways to get your Launchtube tokens. I'm going to read through before we close any questions that I missed that would be important to respond to. Look at that. Raheem was first to comment and the second. Amazing. Option types while using bindings. I don't think Raheem's here anymore, but maybe he'll watch the recording. Yeah, I've had lots of issues with the option type when using bindings. There's a relatively simple understanding, or at least satisfactory one, I suppose, and that's that there is no option type when it comes to bindings. In Sorbonne land, they don't really know anything about option. Option at the end of the day is just a void. Not a void, but a void. So am I still showing my screen? If you go to XDR and you go to SCVal, there is no option type, but there is a void type. So all of option types, regardless of the type that it actually is, a bytes none, or a string none, or a symbol none, it does not matter. They're all going to come back as SCVal, SCV void. That will help some when trying to understand how things come back, especially when you're starting to build out like custom types or interpreters for the TypeScript bindings and trying to understand. There may still be some issue deep inside of like nested types when you're using options. But I've gone pretty deep with the TypeScript bindings with the passkey kit. I've run into some issues, but not too many with using options. And I use options a lot because it does cut down on the number of bytes that you're sending and receiving. So that's nice. Looks like Elliot's been on top of the comments. That's good. Everybody's trying to help me. Appreciate you guys. So kind. All right. Fantastic. Y'all have a wonderful rest of the week. And we'll see you around the Discords. See you, Elliot. Thanks for jumping on. Have a good week.